We now start to create a car layout. For this we use our blank carriage layout shape and select various items we need from the item list. In a first step, we dock a carriage transition to the end of the carriage. For this purpose, we click once on the item we want to select. Click once in the work field and have thus brought the element we want to edit into the work field. When you click on this element, it turns orange and is pre-selected. Now you can click on this element again, stay on the left mouse button and move it. The carriage passage is docked on the outside of the carriage. To place an element precisely against another element or a wall, there is a so-called snapping function. To do this, press the space button at the same time the left mouse button is on the object and it is selected in orange. This will activate snapping and you will see a blue dashed line indicating which object you are snapping to. You can snap inside or outside. It makes sense to snap the car transition outside. Next, we will install the two entrance doors on this side. You can choose between single and double doors. We choose a single wing door here. After clicking on the door, we click on the workspace and have brought the door into the workspace. If you select this element, it turns orange again and you now have various possibilities to configure this element in the settings. For the door we define a length, for example the door cross-section with 1 meter. We assign a name for the door. This is the name that will appear in all evaluations. You have the option of defining where the door is adjusted using X and Y coordinates. The easier way, however, is to snap the element directly to the wall. But now you want to position the door at a specific distance from the side wall. For this purpose, you have the possibility to define different distances for snapping here. In this case, we take the distance to the left and say that the door should be positioned at a distance of 20 centimeters, that is 200 millimeters, from the left wall. There is another setting here in the so-called advanced properties. Here you can define how many entry steps the door has, whether the entry is level boarding, has 1, 2, 3 or 4 steps. In addition, you can say, for example, for level boarding, that you include a gap bridging system. This could be a sliding step or a folding step. They would be bridging a gap between the edge of the platform and the vehicle. You also have the option here to define a physical divider within the entrance door. This is especially useful for double-winged doors or for very wide doors. This could be, for example, a handlebar for double-winged doors that lead over steps into a high-floor vehicle. Here there is a separating element, a holding bar in the middle. Then you can define one or maybe even two dividing elements. This physical separator automatically creates two walking lanes. However, this setting is very rarely used. Usually there are no dividing elements in the doors, but the entire door space is free. We define a high-floor long-distance vehicle here and say from the platform we have an average of 2 steps. Here we are referring to the number of steps that usually must be climbed from the platform to the train. If the platforms are lower, the same vehicle can have 3 steps. If they are higher, it can have just 2 or even 1 step. In addition, you have the option to override default settings. In this specific case, you can define how many people per square meter are allowed to stay in the entry area. For long-distance traffic, 0 persons per square meter for standing areas are defined. However, if you now define a different vehicle, such as in local or regional rail transport, or you deliberately want to operate with standing area in long-distance transport? Then you can, for example, overwrite this value by default in the project setting. Then it applies to all boarding areas. However, if you want to define a different value for a single entry area, you can do that right here. You can decide, for example, that behind the door in the entry area, there should be room for 3 people per square meter. A useful application for this setting is, for example, if you are designing regional train vehicles and have defined a standing density as standard for the entrance space. Now you are designing a first-class vehicle and do not want any standing persons in the first class. Then you can define 0 persons per square meter for this door and its entrance space, if, for example, a first-class room is adjacent to it. You do not have to overwrite these values. You can default to the values that are defined in the project, and if you have created a long-distance transport project, then no standing room will be used by default. These are the settings that you will find in the door. Now you can place the door exactly by clicking on it. Press the space button again, and now you not only snap the outer wall, but also specifically at a distance of 20 centimeters from the left wall. To implement a door with the same settings on the vis-a-vis side, you can easily copy this door by clicking on Ctrl and C in the selected state. This already copies the door. You now click on the element until it is orange, stay on it, click the space button again, and you can arrange the door on the vis-a-vis side. All the settings you have made here will be adopted. It makes sense to give this door a suitable name that is clearly different from the other doors, so that you can also make clear door assignments for the evaluation.